Okay, welcome back to the introduction of graph database. This is like that. So in last video, we talked about how to start a project from Neo4j sandbox. And today we will look at some more advanced project from Neo4j. So first thing is today I will choose recommendations, right? This one is a very popular algorithm that help you to recommend your product, especially like video, movies to the client. Think about if you are working on the YouTube, what kind of movie you want to watch, right? So how it works, let's see this one. Okay, once the database is loaded and you open the browser, you will see this is the recommendations database. There are detailed description here. I don't want just repeat everything here, but just remember this is very good example of how you use graph database to find some clues. In here, what you need to know is we get some similar nodes as the previous video. We have movie and genre, actors, person, user, directors. And here we separate the person into different roles, right? So we can say, for example, let's say user. You get a user like this, okay? So this one would be the person who watched movies. Right? Here's some rated, all those kind of stuff. Let's close it for now. Look at the graph here. You'll see the link between each other. So basically, we have several things in this data set. One is how to think about how to introduce a movie to a user. What can we guess, right? The first thing is we can guess content. What kind of a movie, right? What types of movie that person watched before, right? And each of them has a weight. And if we can find a movie that has some kind of same type of the movie as the movie that I watched before, those movie might be high likely liked by the person. Right, this first way. A second way is collaborative filtering, which is we don't know the movie, we don't know the types of movies, but we know the person who also watched the same movie as the original person, right? So they have some common interests, and we can see some movie from here. You can see those four things the person A did and the person B didn't, did as well, and those two are unique for the person A. But potentially we will say this person may also be interested in those two movies in the future. So we can base on the neighborhood to guess what we like. So first, let's look at the content-based filtering, right? So this is the type of the relationship here. You can try to, if you don't want to write, you can directly click on the query here. It will add to the query writer here. So let's read a little bit. So match a movie in Jerry and also get another direction for other movies. This rec means recommendations movies, right? So they have some common links here, common list of G, and where the title equal to Inception, which is the first movie here, right? First movie is named here, and we want to find all the movie that has some common genre here, and with recommendation collect, which is we put all those genre together to count how many common genres those movie have, and return the title genres, common genres ordered by common genres, right? So we want to find how many relationship they have. Let's run this query for now. We will get this kind of table, which is the first recommendation has a 1, 2, 3, 4, 5, 6, 6 common, right? The number is here. And for the most similar movies, those three are the most similar to the original one, which is the Inception, right? So if you just look at a movie, you can recommend some similar movie to the user. It's very easy to write here. Maybe you feel this query is too long, but we just need to read it carefully. So let's run that part by part. If we want to change the query, you just use / to make it comments, right? So we want to know the match movie, some common movie, right? Let's return m and the recommendation. Let's put a limit here. Maybe it's too many here. Limit 30. I think we also need the G. So you can see the inspection is at somewhere here. Inception is here, and all other movie because linked to the crime here, right? This is only by crime, but this one has more than one genre here. See, matrix, drama. So for the movies that not only linked to the crime but also linked to action, they will have higher score for the similarity, right? Also for like drama, right? Those kind of things. It just depends on what, for any movie, you just count how many link that has common here, right? For any movie, for example, this one has 2, this one has 3, this one has 3 as well, right? This one is only 1. So those kind of things will give you idea which one is best, right? We just need to find the ones with 6. So the next sentence here is collect that and count. This count means how many common links here. So let's return, and let's make a wheel here. Well, common equal to 6. To see those movies, how linked together. Return rec M and G. Okay, so we need to put M here as well. Okay. Oh, M and G. That's the G for now. So you will see this movie has this 3 movie linked to this Inception. If we open that, you can see there are all the links with each other. See, so all those are the types of the Inception, and they also has everything in other 3 movies. So those 3 movies are very close to the original one. And if you choose greater than 5, let's see what happened. Greater than 5. Let's put the match. Return rec M and G. So you can see we have some difference here. So inceptions on the left side, and if we put all the types in the middle, we will see clearly. Or this is greater than 5. Let's say greater or equal than 5. Greater than 4. So more movies here. So inception is here, and we want for any movie here, you will find a count either 5 or 6, right? Not too many. So you just need to count. So this one is 6, this one is 5, right? You just count these numbers, you will get which one is the best, and you rank by name. So that's how this relation work. So with the original query here, you get the idea. So this simple query just finished all the recommendation we have. Okay, and we also have a modifier here. So if you know the person, how do you find the recommended? So the first thing is match the person here, and he has some rating for the movie, and also the movie is in some type, and we base on that. This is the exact same as before, right? So the only difference is here the M is defined by this person, and will not exist the U rated rec. So this one means the recommendation cannot be viewed by the person before, right? We don't want to recommend the same movie. Like my experience in YouTube, they always send me some like a video I've watched before. That's not what I like. So we need to add it here. And with the rec, we count the score, right? This count is same thing as before, g.name, and return the title, right? All those kind of stuff. And this is a reduce. If you don't know reduce, let's run this query first, and then I can explain later. So it's run for a little bit. So the recommendations, we get a score 37, which is highest one for that person, and 33. So the reason why is the weight for those different types, right? So this movie has all those scores. We add them together, we get 37, right? For how many common links here. So let's break up this query here. First one is the user rated movie. So I think we don't need to write that, put that out. And this one expand that, and will not exist here. Okay, so let's change this with to return, and put double slash. Return the score and the recommendation. Too long. Let's add a limit here. Okay, stop. So this one gives us all the node. And another thing in Neo4j is if you has a node as a result, it always return your graph. But also you can click here for the table. So you can see, once you click on the table, you can see this kind of dictionary is the node for recommendation, and you get scores, right? Get scores. And however the scores, you will find the same node will have more than one entry here, more than one row here, right? So it may have some score for adventure, it also has some score for drama, all these kind of things here. So you just need to put them together, which is this collect do, right? This collect do. Collect is, for example, one single movie has 2 rows in this result. We just put these 2 rows into one. Every row actually, not maybe sometimes 2, sometimes 5. We put them all together into a list. If you never learned the list before, think that's kind of a container to contain all those. To change this one into the format of the below one. Below one, like this, right? You can see this bracket here. This is kind of list, and within that we also have 2 elements here, which one is a type, another one is how many scores. And we have another weird thing here is reduce, which is something like a programming language. So it starts from 0, and for every x in this collected scores, which is this element, see? This element is each type x presents for one of each of those. And s at the very beginning equal to 0. And s plus x1, which means the second part, we start from 0 in the list. The second part, which is 5. So first time 0 plus 5, second time 0 plus 10, third time 0 plus, not 0, sorry. The first time 0 plus 5, then it's 5. Then the s becomes the 5, right? And the second time, the s, which is 5, add 10, which is 15. And 15, add 3, add 6, add 6, add 1. So it's kind of weird for you, but you can think like if you see the plus side here, it's just like a sum the total, right? The total score, which is how this 31 come from all these numbers, right? If you get this kind of thing, it's hard for you to count just the partial of these elements, and we order the scores by turn. That's how you get the recommendations for this person. Okay, I think this is the first glaze of how the recommendation works. If you want to learn deeper, you can watch my next video to talk about how to recommend the movie by person, and how to use different algorithm to put it better here. Because we see some like we didn't consider that how much the rating, and we didn't consider how important each of those types. So we will know that from the next video. But if you want to play by yourself, you still can just go through the tutorial. It has very detailed information here. And if you don't want to write cipher, you just run the cipher, and just like as what I did, put it apart one by one to see what it's doing here. Right? It takes some time, but once you figure that out, you get a much better understanding for the algorithm. And that's the beauty of graph database. You can see what you are doing here. Okay. See you next time.